Hello and welcome to Grace Tutorial. In this video lecture, we will be discussing about one of the most important chapters of +2 second year chemistry, that is aliphatic amines. Well, first of all, let us try to understand that what do you mean by this amines? Amines are basically the derivatives of ammonia. So how the amines are defined? Amines are defined as the derivatives of ammonia. Well, these are the organic compounds, no doubt, but how the amines are generally obtained? The amines are formed when one or more hydrogen atoms are replaced by the alkyl group or the aryl group. That's why it is said that the amines are defined as the derivatives of ammonia. Suppose what I have ammonia, and this ammonia is connected with hydrogen atoms. Suppose if one of the hydrogen atom is replaced by the alkyl group R, then how do we write this one? So this is an amine. And sometimes this hydrogen atom of the ammonia can also be replaced by an aromatic compound. That means it also can be replaced by a benzene ring. That means, first of all, here it is very easy to understand that what do you mean by amines. So amines are defined as the derivatives of ammonia, the alkyl or the aryl derivatives of ammonia. That means when one or more hydrogen atoms are replaced in the ammonia, then it forms amine. So when the alkyl group or when the nitrogen atom is directly attached to the alkyl group, then that amine is called the aliphatic amine. Aliphatic amines. So what do you mean by aliphatic amines? When this nitrogen is directly bonded to the alkyl group, then that is called aliphatic amines. Similarly, when this nitrogen group is directly bonded to the aryl group, then that is called aromatic amines. Let me make you very much clear. Here we are studying about amines. But what is this amine? Amines are defined as the derivatives of ammonia. That means when one hydrogen or more than one hydrogen is replaced by the alkyl group or aryl group, then amines are obtained. So these amines can be of various types. It can be aliphatic or it can be aromatic. So which amines are referred to as the aliphatic amines? When the nitrogen atom is directly bonded to the alkyl group, then that amine is called the aliphatic amine. Similarly, when this nitrogen group is directly bonded to the aryl group, then that is known as the aromatic amines. Let me give you some of the examples of the amines. So if you look at it very carefully, that in each ammonia group, the hydrogen atoms are replaced and alkyl groups are attached to that. So these are the different amines. So what is the name of this amine? The name of this amine is methyl amine. Methyl amine, or we can say the methanamine. Similarly, what is the name of this compound? This is ethyl, and this ethyl is connected with amine, that's why this is ethylamine. Similarly, here also amine is there, but here the two methyl groups are attached, that's why the name of this compound is dimethyl amine. Similarly, here three methyl groups are there, that's why it is trimethylamine. So what all the examples that I have written for you is aliphatic amines, because these are open chain compounds. Well, let me give you some of the examples of the aromatic amines as well. So what do you mean by the aromatic amine? When the nitrogen atom is directly bonded to the aryl group, then that is what called the aromatic amines. The amines which is obtained, those are aromatic amines. The example is that, suppose I have benzene, and when this benzene is connected with NH2, this is the name of this compound is aniline. Similarly, I have toluene. Here amine group is attached. This is toluene, right? This part. This is toluene, and when amine group is attached to that, then this is orthotoluidine. Let me give you the another example. Diphenylamine. So it means here the amine group here, in all the three cases, the amine groups are attached to the benzene rings. That means the amine groups are attached to the ring compounds. That's why these compounds or these amines are called the aromatic amines. So what are we actually discussing here? The concept is very simple to understand, my dear students. The chapter is aliphatic amines. So the first doubt, so if the first question, you need to make clear to the first question that what is amine? Amines are simply the derivatives of ammonia. Why? Because the amines are obtained from the ammonia, that's why it is called the derivatives of ammonia. But how? I have ammonia NH3, if one hydrogen or two hydrogens or more than two hydrogens are replaced by the alkyl group or the aryl groups, then amines are obtained. If those hydrogen atoms are replaced by the alkyl groups, then those amines which are obtained are called the aliphatic amines, which I have just shown you the examples of aliphatic amines, where the direct chain, that the open chain is there. Similarly, if the hydrogen atoms of the ammonia are replaced by the aryl group, that means a ring compound, then those amines which are obtained are known as the aromatic amines. So I hope you understood that what do you mean by this aliphatic amine and aromatic amines, and the various examples of the aliphatic amines as well as the aromatic amines are given for you. This one, methyl group is attached to the amine, that's why it is known as methylamine. Similarly, ethyl group is attached to the amine, this is called the ethylamine. Similarly, here dimethyl, so dimethyl and amine, this here, but here the three methyl groups are there, that's why it is called the trimethylamine. And all these compounds are open chain compounds, that's why these amines are called the aliphatic amines. But if you look at here, these compounds are the ring compounds, that's why these amines are called the aromatic amines. Look at here, this amine group, that means the hydrogen atom of the ammonia, because we have ammonia NH3, the hydrogen atom of this ammonia will be replaced by a benzene ring, and that's the name is called the aniline, and it is a compound which comes under the group of amine. Similarly, here the hydrogen atom of the ammonia is replaced by a toluene. So what's the name of this compound? The name of this compound is orthotoluidine. Similarly, here the hydrogen atoms are replaced by both the phenyl groups. That's why this is known as the diphenylamine, and these are the different examples of aromatic amines. So aliphatic amines and aromatic amines. I hope it is very clear for you. Now we will discuss about the different types of amines, that means the classification of amines. Well, if you look about the classification of amines, amines are classified into various categories. So the first one that I would like to tell you is that primary amines. So what do you mean by primary amines? Suppose you see I have ammonia. You know that the amines are the derivatives of ammonia. If this ammonia, the hydrogen atom, if one hydrogen atom of the ammonia is replaced by one alkyl group, that means one hydrogen atom of ammonia is replaced by one alkyl group. So what the product is obtained here? RNH2. And this is what called a primary amine. That means, first of all, it is very clear that the amines are the derivatives of ammonia. But if one hydrogen atom of the ammonia is replaced by one alkyl group, then that is called primary amines. So let me give you some of the examples of the primary amines. Suppose I have CH3NH2. The name of this compound is methyl amine. Methyl amine, or we can say methanamine. So methyl, and here amine group is, that's why methyl amine, or according to IUPAC name, this one methane plus amine, that is methanamine. Similarly, I have so what is the name of this compound? This one is ethyl. So ethyl amine. Or tell me what's the another name? Ethanamine. Let me give you one more example. Suppose I have CH3, CH3, here it is NH2. So this is isopropyl amine. Isopropyl amine. Suppose I have CH3, CH, CH3, CH2, NH2. This is how many carbon atoms are there? 4 carbon atoms are there. So this is isobutyl amine. The name of this compound is isobutyl amine. Suppose I have tertiary butyl amine. Look at here, my dear friends, the first one, if you look at the classification of amines, the first one we have the primary amines. So what do you mean by this primary amine? When one alkyl group replaces the hydrogen atom of the ammonia, that means when one hydrogen atom of the ammonia is replaced by one alkyl group, then this is called the primary amine. The amine which is obtained is called the primary amine, that is RNH2. And I have given you the various examples of this primary amine. CH3NH2, the methylamine or methanamine is an example of primary amine. Similarly, ethylamine or ethanamine is also an example of the primary amine. Similarly, isopropylamine, isobutylamine, tertiary butylamines, these are the different examples of the primary amines. Move on to number 2, that is secondary amines. So what do you mean by secondary amines? I hope you can guess it, right? Well, if one hydrogen atom of ammonia is replaced by one alkyl group, then the amine which is obtained, this is primary. Similarly, if two hydrogen atoms of the ammonia are replaced by the two alkyl groups, then the amines which are obtained are called the secondary amines. Let me show you. This is NH3. And if this ammonia is replaced by two alkyl groups, so the two hydrogen atoms of the ammonia had been removed by the two alkyl groups. So what is obtained here? RRNH. So this is called the secondary amines. This is primary amine. So secondary amine. So what are the examples of the secondary amine? Let me show you. Suppose, let us put the methyl group here, CH3, NH. So what is the name of this compound? Dimethylamine. So dimethylamine. So dimethylamine is also, it is one of the best examples of the secondary amine. Similarly, let me give you another, that is CH3NH, CH2, CH3. Look at here. Here, of course, two alkyl groups are there. One is methyl and another ethyl. Since the two alkyl groups are there and NH, therefore it also comes under the secondary amine. So what's the name of this compound? Here first of all, ethyl methylamine. So ethyl methylamine. Ethyl methylamine, you can say. Suppose if you will put C2H5 NH C2H5, then the name of this compound is, both ethyl groups are there, so diethyl amine. So this is what all about the secondary amines, wherein the two hydrogen atoms of the ammonia are replaced by the two alkyl groups and the secondary amines which are obtained here, and the specific examples of the secondary amines are given for you. Well, I hope the primary amines and the secondary amines with the examples are very clear for you. Now we move on to the third type of the amines, that is tertiary amines. So if we look at the third type of one, that is tertiary amines. So how the tertiary amines are obtained? I have ammonia. If this ammonia is replaced by three alkyl groups by the removal of three hydrogen atoms, then the alkenes, then the product which is obtained is tertiary amine. So if one hydrogen is removed by one alkyl group, then that is called the primary. If two hydrogen atoms are removed by the two alkyl groups, that is secondary. Similarly, if three alkyl groups, if three hydrogen atoms are replaced by the three alkyl groups, then that is called the tertiary amine. Let me give you the examples of the tertiary amine. Suppose I have CH3 CH3 trimethylamine, Similarly, suppose I have so if you look at here, 3 alkyl groups are there. First of all, ethyl and 2 methyl. So ethyl dimethylamine, ethyl dimethylamine. Yeah. So trimethylamine is one of the examples of the tertiary amine. Similarly, since 3 alkyl groups are there, that's why these 3 alkyl groups, it replaces the 3 hydrogen atoms of the ammonia. That's why it is called the ethyl dimethylamine. And ethyl dimethylamine also comes under the tertiary amines. So I hope the primary amine along with the examples, secondary amine along with the examples, and the tertiary amine along with the examples and the names of the compounds are very clear for you. So we have one more, that is quaternary salt. Quaternary salt. How the ammonia, it forms the ammonium chloride. Similarly, this ammonia also forms the salt, the quaternary salt. So let me show you. Suppose you see that is ammonia is there, right? If the ammonium reacts with chloride, it gives ammonium chloride. Similarly, suppose I have tertiary trimethylamine. Suppose I have trimethylamine. Look at here, 3 methyl groups are there, CH3 and N. So trimethylamine. When this trimethylamine reacts with methyl iodide, then the compound which is obtained is basically a salt, that is quaternary salt. So what's here actually obtained? Here N plus CH3 and here 3 and one more alkyl group, that means CH3 whole 4. This is I minus. So tetramethyl ammonium iodide, tetramethyl ammonium iodide. So tetramethyl ammonium iodide, this is actually a quaternary salt. That means the amine can also form the quaternary salt. So this is what I have just shown you, and the name of this one is trimethylamine. And here methyl iodide. Yeah. And finally, the tetramethyl ammonium iodide is obtained. This is all about the quaternary salts. So the main things, if in the classification that you need to remember, this quaternary salt as well, along with the primary amine, secondary amine, as well as the tertiary amines. And if you will write one by one, so that it will be easy for you to understand every bit of the lecture. Well, this is all about the classification of amines. Now we will discuss one of the most important part of this one, that is nomenclature of amines. So nomenclature of amines refers to the naming of amines. Basically, the chemical compounds are named on the basis of 2 factors. One is the common name, another according to the IUPAC system. So we have the amine R and H2. The primary amines, secondary amines, and the tertiary amines are there. But how can we name the primary amine? How can we name the secondary amine? Similarly, the tertiary amines are named. How the tertiary amines also can be named? Well, suppose I have, compounds. Here I have amines. and here it is I common name. Let us write common name. And here it is IUPAC name. So I know the functional group of amines. The formula, the general formula of amines is RNH2. So suppose if I will take the primary amine, suppose let me take the primary amine, the first one that I have. If you will place here the methyl group, then what is obtained? CH3 and H2. So methyl and here amine is attached to that, that's why it is methyl amine according to common name. Methyl amine. Well, but IUPAC name, the IUPAC name is something slightly different from that of common name. Here methyl group is attached to this amine. So what happens here basically, if you look at here, suppose I have methane. Well, if this hydrogen atom of the methane is replaced by NH2, then I can say, just how you can say, suppose you see, if the same hydrogen atom is replaced by NO2, then you can say nitromethane. I just try to understand it very carefully. If the same hydrogen atom of the methane molecule is replaced by a nitro group, then what do you say? How do you give the name to that compound? It is a nitromethane. Similarly, if this amine group is replaced, so if this amine group has been placed here, removing this hydrogen atom, then we can say methane plus amine, that is methanamine. Methanamine. Similarly, let me write one more thing, that is CH3, CH2 and H2. So this is ethyl. CH3 CH2 is basically an ethyl, and ethyl reacts with amine, so this is ethylamine. Similarly, in IUPAC name, here it is ethanamine. That means here this ethane group. So what generally happens here, how the hydrogen atom is replaced by the amine group, that's why in methane, M-A-T-H-A-N-E, the last E letter will be replaced by the amine. How the hydrogen atom is replaced by this NH2 group, similarly in the word methane, the last letter of the word, that is E, will be replaced by this amine, and in this way here it obtains methanamine. Similarly here also it obtains ethanamine. That means the last letter of the word ethane, E, has been replaced by the amine. So what is the name of this compound? Ethanamine. Well, let me write one more example. This is all about the primary. Suppose I have written if you look at here, how many methyl groups are there? 2 methyl groups are there. So this is dimethylamine. Dimethylamine, or you can say N-methyl methanamine according to this IUPAC name. N-methyl methanamine. Similarly, suppose you have CH3, CH2, CH2 and H2. So here propyl group is attached, so this is N-propylamine. But according to IUPAC name, So this is propyl, that means propanamine. Propanamine. So the last letter of the propan, that is E, will be replaced by this amine. So this is propanamine. Similarly, butanamine. In this way, here it obtains. Suppose I have CH3, CH3, CH3N. Here it is CH3 and here also it is CH3. So trimethylamine. Trimethylamine. But this is N-methyl, N dimethyl methanamine. N dimethyl methanamine. So this is what the IUPAC name of this compound. So here I have written the various examples of the aliphatic amines. The amines, according to this formula, according to the general formula that I have written, the amines, various amines, and how the common names are obtained and how the IUPAC names are obtained. The common names are obtained in a very simple way. That means the formula which is there, that you need to split the formula so that you can get it. This is methyl and this is amine. So methylamine, it's very simple. Similarly, this is ethyl and here it is amine. So ethylamine. In this way, the common names can be given by using the splitting method. So it's in this way every common name is written so way. So IUPAC name is slightly different to that. IUPAC name is very different. How? Look at here CH3NH2. That means suppose CH4, the methane group is there. One hydrogen has been replaced by one amine group. So that is what called, how. That means first it was methane, but when the hydrogen is replaced by this amine, so this E will be removed and here it will be written amine. So now tell me, what is the name of this compound? Methanamine. So this is what the IUPAC name. Similarly, you will have to remove the last letter of the alkane group, and finally the name which are obtained, those names are called the IUPAC names of aliphatic amines. So this is what all about the various examples related to the common names as well as the IUPAC names of the aliphatic amines, along with the formula of the given general formula. So I hope it is very clear, the nomenclature of amines. So why did we discuss the nomenclature of amines? Because without having a clear analysis, without having the understanding of the names of the given compounds, it's very impossible to understand, to move into the general methods of the preparation, similarly the chemical properties, and to discuss the various basicity, something like this. These parts of these things that you need to understand in a very detailed, systematic manner. That's why the name of each and every compound of the amines have been discussed in a very clear-cut manner. I think it is very clear to you. Well, now we will discuss another important part of this chapter, that is the isomerism.